Alright guys, welcome to lesson 2.9. We're going to be talking about integrals that result in natural log functions today. Alright, so you guys remember this from Unit 1, that the derivative of ln is 1 over x. Well, today we're working backwards. We're going to integrate 1 over u, and that's going to give us ln of u. Now you got to be careful. Notice there's an absolute value sign in there, and the reason for that is because natural logs, you're not allowed to have anything plugged in that's less than or equal to 0. So there has to be absolute value signs on there to make sure that you're not getting any negative answers. But that's our little formula for the day. And a lot of these are going to be just solved with some u substitution used as well. So let's go ahead and begin here. So we'll start off with something pretty basic here, number 1. So first of all, number 1, I would take the 2 out, just so it looks like what it's supposed to. Oops. Instead of u, though, we have x, but that's okay. That's not a big deal. According to the formula, when you integrate 1 over x, you get ln of x, right? But we have the 2 in the front, so I'll put that there, plus c. So this is a good answer. Now, just so you guys know, there's a little rule about logarithms that says whenever you have a natural log being multiplied by a number, you can also write your answer like this, where you take this multiplier and make it a power on the x. So either one of those are good answers, but that's a log property there, just so you know. I don't know which one is more likely to appear on your answer keys and all that, but if you guys look at your homework, you'll know. But I would definitely be aware of both because it can go either way. So that's basically it. Okay? So why don't we have you guys try one like that real quick. Try number 1 and see what you guys get. And there you go. You know, I just realized on my problem I forgot to put the absolute value bars. Shame on me. Just so you guys are aware, once again, whatever's on the inside of these absolute value bars, if it has an even power on it, you don't have to have the bars there because even powers make everything positive anyway. But there it is. So there's that basic idea. Now, I just want to talk about something really quick about what we don't do and why we don't do it. So we've done problems like this before, but we handle them very differently. And I want you guys to see why we're not doing it that way this time. So, for example, if I gave you guys this, what we did before was we moved the power up to the top like that, right? And then we added 1 to the power to integrate it. And then we divided by that number. And then we simplified. Right? Well, we don't do that on today's lesson, and why not? Well, the reason we did it before is because this was a power of 2, or it could have been any other number. But whenever you have a power of 1, this strategy won't work. Let me show you why. So let's start it like this. Let's say we had that, right? Well, if we tried to use that strategy, move that x up to the top, right? Add 1 to the power, what do you get? Get 0, and then you divide by 0. You're not allowed to divide by 0, though. That doesn't make sense. That doesn't work. That doesn't mean there's no solution. It just means that this strategy for finding the integral doesn't work. Okay? So you can't do it this way whenever the power's a 1 on the bottom. If the power's a 1 on the bottom, this is how you do the integral, okay? So if you have any other number down here, you do it the way we did before, where you move it to the top, you make the power a negative, and then you can just do the power rule. But if you have a power of 1 down there, then you have to use natural logs. So they look similar, and yet the way you handle them is quite different. All right, but I digress. Let's look at some other types of problems here. Let me go back to the examples. I think a good one to do would probably be number, gosh, these are all kind of ugly looking. I guess we'll just do number 2. So let's do number 2. Now at number 2, well, in case you haven't noticed, this doesn't look like anything that we've seen so far, right? I mean, it doesn't look like, you know, the arctans or the arcsecants. It's a little weird. So what we're going to do with this one is we're going to do a u substitution. And we're going to let the bottom equal a u. Okay? And if I do that, that means du dx is equal to 2x plus 2. Then we want to get the dx by itself. And then we're going to do some u substitution. So the top is x plus 1. The bottom is now u. The whole bottom just becomes u. And the dx becomes du over 2x plus 2. Now, I want to show you guys a funny little algebra move here. The one I give you may or may not require this. We'll see. But it's something you can do. For this one down here, I'm going to factor a 2 out. Why did I do that? Because now I can cancel the x plus 1s. So, I'm also going to factor this constant out. Since it's in the denominator, though, it's going to be a half when I factor it out. All right, and then now it looks like a natural log integral, right? So now I have 1/2 ln absolute value of u plus c. And of course, at this point, we want to replace the u with what u was equal to. U was equal to x squared plus 2x. And we're good to go. Now, once again, I mean, if you wanted to, you could take this thing in the front here, multiply it as a, or not multiply, but make it a power. And anything to a half power is also a square root. So this is a possibility also for an answer, just so you know. It will probably be this one, but this is a possibility as well, because the multiplier can become a power, and a half power is a square root. A couple things going on this one, though. So here's the big thing that I want you guys to know about this. We did u substitution, and we made the u equal to the denominator. So that's the main strategy I want you guys to get. There's a couple of other weird things along the way. Like after we did our u substitution, I had to factor a 2 out, and also I moved that to the outside. Those were two other weird little details, but for the most part, here's what I really want you guys to remember about this particular problem. You make the denominator equal to u, and you solve it. So let's take a look here. I want you guys to do number 3. So do number 3 for me. See if you guys can figure out that one. Pause the video. When you unpause it, you'll see the solution. Okay, so first thing we would want to do here is do your u substitution with the u being equal to the denominator. And we're going to replace the bottom with u. Also on the top, I factored a 10 out, so we have x minus 2. And when I put the du over 2x minus 4, I factored a 2 out. There. That way the x minus 2's go away. 2 goes into 10 5 times, and I put the 5 on the outside. From there, we have the nice ln set up, and you're ready to apply the formula to get your final answer. Okay? All right, let's take a look at another one here. So for this one, once again, we're going to let the bottom equal u. take the derivative of that. The derivative of tangent is secant squared. Got to think back to Unit 1 to remember that. Get the dx by itself, and then do your u substitution. The bottom was u. We replaced the dx with du over secant squared x, and those go away, leaving me with a nice simple expression. That's our ln formula there. So to integrate, we do absolute value of u plus c, and the u in this case was tangent x. There you go. So that's just one with trigonometry in it. I'm going to let you guys try one with trigonometry here. So for this one, I want you guys to do integral of tangent. But to do that, I want you to understand that tangent can be replaced. The first step is I want you guys to replace tangent with sine x over cosine x. And then from there, I'm going to let you guys take it. Okay, so pause the video here and then finish that problem up. Okay, so for this one here, after starting here, we let u equal the bottom. And once we do all the steps we usually do for u substitution, we replace the bottom with u. We replace dx with our du expression there. The sine x's go away, but we still have a negative that needs to be taken out, so we've moved that to the front, and we're left with this. Now, we're going to have a little bit of fun here just to mess around with you guys a little bit. As you guys know, I can write it like this, right? I can take the negative and make it a power. But what does a negative power do? Negative powers make reciprocals. And what's 1 over cosine? So you could write your answer like that, technically. So the negative can be a power, which makes a reciprocal, which makes secant. So just messing around with some different options. You guys might be thinking, oh man, does he expect me to know that? Well, I think it's worth reviewing. I don't really expect to give you stuff like that on a normal test or anything like that, but definitely stuff you want to know. It could pop up like on homework, or technically even on an AP exam. It's possible. They don't usually get too creative with old pre-calculus knowledge like that, but it's possible. All right, let's do another one. Now, number 4 is special because it's a definite integral. So what does that mean? Well, first of all, there's a couple things that I want to point out to you about number 4. First of all, look at the dx. Why? They put it on the top. That's really weird. So my advice to you is when they do that, and they're going to do that once in a while, when they do that, just go ahead and write it like normal. Put the dx on the side. I don't know why, but sometimes they'll do that. They'll put the dx on top because they can. I mean, technically, this is dx over 1, right? So you can multiply straight across. But this is kind of weird. So my suggestion is just go ahead and leave the dx on the side. Anyway, now we're going to go ahead and begin. So the first thing we're going to do is we're going to do some u substitution here. I'm going to let u equal 4x minus 1. And therefore, we're going to have a new expression. It's going to become 1 over u and du over 4. But, you guys remember this, but when you have a definite integral, the limits have to change also when you do u substitution. Okay? So, what I need to do then is I need to plug these numbers in. So I'm going to plug in e squared into here. So now the upper limit's going to turn really weird. It's going to turn into 4e squared plus 1. And then we also have to plug in the bottom limit, That one's a little bit nicer. 4 times 1 is 4, take away 1 is 3, so that one's a little bit simpler. The next thing I want to do is I want to factor this 4 out, so I'm going to move it to the front there. So there's another little quirk. Okay. So first thing is I didn't like the dx on the top, so I moved it to the side. That's something I want you guys to be aware of. Next thing, we're reviewing that when you do use substitution with definite integrals, you have to change their limits also. Okay. But now that that's done, we can go ahead and do our integration because this fits our ln formula pretty well. And now we do the fundamental theorem of calculus, right? We plug this stuff in, so we have 1/4 bracket minus 1/4 bracket. And we're going to plug in what they gave us there. And technically, these are supposed to be in absolute value bars, but here's the thing. I don't need to do absolute value bars anymore. Why not? Because e squared is positive, and we're multiplying it by a positive, and we're adding a number. So this whole thing is already positive, so we don't need absolute value bars anymore. And what about here? We don't really need that either, because absolute value bars there either, because it's a positive 3. So we're good. Now, technically, I don't care if you guys just want to leave the answer like that, because at this point, it's just going to be kind of ugly. But just for fun, I'm going to review some more rules with you here. So, first of all, I'm going to take this 1/4 out really quick. Okay, so I'm just going to factor out the 1/4. So I'm going to take it out of both of these and just put it in the front. Why did I do that? Well, because there's a rule about logarithms. When you have 2 logs that are being subtracted, you can actually combine them into a single logarithm, where the first one is being divided by the second one's argument. There you go. So that's another. So even though this is a perfect answer, and you can stop there if you want to, we can also do this. Now, since this is a 1/4 power, though, I mean, we can also make that a 1/4 power, which means another way you could write this is as a 4th root. Once again, I'm pretty sure that on your test, we're just going to be having stuff like this, but I wouldn't mind you guys being aware of these kinds of things. These kinds of things can come in handy along the way. It's good to remember our log properties. Okay. So, you don't need to necessarily know all those. I just really wanted you guys to see the 2 main things was taking the dx off the top, putting it on the side, and then doing your u substitution and not forgetting to change the limit. Whatever else you could do with it, go for it, but those 2 things I really want to make sure you guys know how to do. So, here is yours. Go as far as you can with it. Do what you can with number 4. Okay, so first of all, little subtle detail. Want to make sure that you know the dx. We like to have it over here. Doesn't really matter, but it looks nicer. Next, I did my u substitution where I set the bottom equal to u and solved for dx after that. Then, by doing our u substitution, here's the really important thing. This should have been, oh, I just realized I didn't have an over 2 here the whole time, darn it. I was going to change my answer. Anyway, so after doing our u substitution, this is what you would have. You would have 1 over u, du over 2. The upper limit would have changed into this, and the lower limit would have changed into that. Next, integrating next we should take out the half, right? So take that 2 out and make it a half in the front, so we can do the natural log rule on this. So now we have a 1/2 natural log of the absolute value of u with our 2 limits here and here. Plug in your upper limit and your lower limit. Subtract them. And once again, you can take the half out and just take these 2 things and make a fraction out of them, because that's a property of logarithms. And then technically, if you wanted to, you could even write it as a square root. Since there's a half in the front, you could make that half a power, and a half power is a square root. So this is a fine answer, but either of these are also good answers down here. Okay? So that is doing U substitution with the natural log rule, and that's where we'll leave that lesson.